All right. Let's do some recording of some CISSP stuff. Glasses would help. We'll see what kind of trouble we can get into. All right, so I am recording PPP, point-to-point protocol. And questions are... Oh, okay. I can share slides. Okay, so here we go. We need to record point-to-point protocol. It's very exciting. But if you're testing CISSP, it is something that you should know. So, all right, have I clicked record on my... I haven't clicked record. Did I? Oh, all right, here we go. All right, so here we go. All right, let's record some point-to-point protocol. So this is definitely something to know for this test. There's maybe a question. Given the number of questions we have on the test, I don't think you'll see a lot of this, but it could definitely show up. There is security. So remember with my questions... All right, so my three basic questions when it comes to networking. First question is, what's its purpose? Second question is, what layer of the OSI model? And this is layer 2. Third question is there any security designed into it? And the answer is, yeah, a tiny bit on this one, which is why it goes into the grouping of you could see this. All right, so first thing is purpose. The purpose of this protocol, there's a long history on how we got here, and there's previous protocols that I've seen in the IAC² books still today, like CISSP, and you don't need to know that just to save you some time on studying that. But there are previous protocols that got us here. What happened is when building out networks, if we're in a building... I can't draw, so it kind of looks like a house. We're in a building, building out a happy house. We're building out our local area network. And then we have a car or a parking lot. And then we have another building on a campus. And we build a LAN inside of there. And we need a campus area network to be able to connect the two buildings to each other. So we have a router in one building, a router in the other building. And if it's just going across the parking lot, we're not going to go and call AT&T or T-Mobile or somebody like that to come and connect those two for us. So we're going to just pull a wire, layer 1, across the parking lot, dig a trench, bury it, and we've now got a router connected to a router. So we have layer 1, and we can transmit our 1s and our 0s. But we need a layer 2 protocol to frame so that we can keep traffic separate from each other. And we end up at PPP, point-to-point protocol. So it's literally one point router to another point to points. That's the only purpose to this thing, is to be able to connect two routers to each other. But inside of point-to-point protocol, when you get into this frame and you look at the frame header, there actually is room for authentication. There's room for authentication. Authentication being access control, kind of, sort of, basically. Previous protocols like CISSP, we just connected two routers to each other and they just start sending frames. But what if somebody were to tap into this wire and plug in a fake router, or disconnect the wire, cut the wire, plug in a fake router? How do we know this is our router versus an attacker's router? So somebody realized that we need to, maybe authenticate, something like a password. If one router was to send a password to the other router, then we could authenticate and make sure that it is our router and we know who it is that we're talking to on the other side. And in comes PPP. And our first version of authentication we have is PAP. So there's an evolution that occurs here from PAP to CHAP to EAP. So PAP is it's designed into point-to-point protocol. It is the authentication mechanism inside of point-to-point. Point-to-point gives you your frame. And then how do we send the password? What's it formatted like? What's the size of the password? What are our options? Anything like that is built into password authentication protocol. But this thing actually has a few problems to it. First problem is the password is in the clear, which is just not good. I remember it took about a year for people to realize this, and then we came up with the next version. I wasn't involved in coming up with a new one, but when CHAP came out, we realized, oh, yeah, we need to switch to CHAP because password's in the clear. I'm old. I've earned my gray hair. So password authentication protocols in the clear. CHAP is going to fix that by hashing the password. Now, we know today that you don't just hash a password, you should salt the hash. And CHAP actually does that. CHAP has a, what's it called? It has a random number that's used for hashing the password. And in CHAP, it's called a number used once. And we say nonce. Oh, and I want to say in the UK, they're laughing right now, but that's a story for another day. All right, so we have a number used once that is our random number that we're going to use to hash the password. And things are better. But both PAP and CHAP have a similar problem. They're used to authenticate the router. It authenticates a device. It authenticates a node, not a user, which is fine when we're talking about router-to-router connections. I mean, that's exactly what we need. And evolution carries on. And at some point, wondering, could we possibly extend that out to a user? Could we use this in another scenario? Point-to-point, pulling a wire across the parking lot, that still happens, still needs to be done. But how could we use this technology of authentication in other scenarios? And EAP is developed, so it's extensible. It extends to the user. Extends all the way out to the user. I'll change my color here. This part will get edited out, but this pink is not working well. Maybe blue. That's better. Okay. All right, so extending out to the user, that's the key with extensible authentication protocol. So EAP actually supports user authentication and one factor. It can support one factor of authentication or two. So our factors of authentication we'll get into in the identity and access management, but you probably already know 3 factors, something you know, something you have. Depending on the vendor that you're using, EAP can support 2 factors of authentication. So you could have a password and a token. You could have biometrics and a token, depending on the vendor. So I've seen this in use in a lot of different places. One place that we have pulled it in is 802.1x. X is usually a variable, but not with that protocol. 802.1x is a security version, a security protocol designed for wireless. And it does pull in extensible authentication protocol. It has more to it, which is why it's not just EAP. So we'll find that somewhere else later on. So it is EAP and Radius together. That makes sense? Great. If not, just make a note about it, and we'll get into it in another video someplace else. EAP gets used in other places. All right, now, is there anything else that you need to know? All right, so I have slides here or space on each of these. So passwords are sent in the clear. That alone is enough to make us leave it. but it is a static password that's stored in the device. So again, that's node authentication. Because it's stored in the router, it could remain there for years. Not a good choice, but that is history, and it is a version of security. CHAP is going to use a random number used once, in order to salt the hash of the password, which actually makes it better. EAP actually carries that over. So EAP is going to use that hashing of a password with a random number pulled in. So that's good. It allows for possibly two factors of authentication depending on the vendor. But hashing the password, even salted hashes, we could do better. So there are variations of EAP, like EAP TLS, EAP tunneled TLS, PEEP, password, or no, it's protected EAP, or LEAP, which is lightweight EAP. So if you see these letters EAP in the middle, it is this. It's just a variation on it. So most of these, what we're doing is we're encrypting. That's the key thing, is encrypting it, not just hashing the password, but let's encrypt that transmission. So EAP is extensible, and it does build out, and it is the best of the choices. So PAP, CHAP, and EAP. If you can keep it in that order. I don't have any memory joggers for that. I just say PAP, CHAP, EAP. I always say it in that order. So if you get in that habit, then that could help you keep that straight in case you run into it in the test. But that's it. Point-to-point protocol. So just a little bit. So those three questions. What's its purpose? Point-to-point, and it has authentication. Second question, it is layer 2. Third question, does it have security? Yes, authentication. All right, side note, little memory jogger for you. If we have a protocol that actually has the word security in it, like transport layer security, this is consistent across all the protocols. There might be an exception, but everything we need for CISSP, this is gonna work. If the word security is in there, we have two things from security. We have authentication and encryption. If we say it's security password, well, it says the word password, or CHAP, or all of these say authentication in the middle of it. But if we say PPP, point-to-point protocol, and there's nothing in the name that actually says security in any way, shape, or form, and in the question it's clear that there is something that is security, what is this? I don't remember what this is. It's just authentication. So if security isn't in the name, and password authentication protocol literally tells you it's authentication because it's a password. But if the word security is not in the name, it's just authentication. If the word security is in the name of the protocol, it is both encryption and authentication. Short version. That actually might get you through a lot of questions without digging into things, or in the exam if you forget something. All right. Memory joggers are great. That's it for this one. I will see you in the next video. And nobody joined me in the live. Oh, well. That's okay. I was only online for 14 minutes. All right. Bye-bye. All right. I wanted to see.